Okay, here we go. Factoring part 1. There are going to be 2 parts to this. Here's the first part today. We'll do the second part tomorrow. We're going to start by factoring using algebra tiles. And so the reason this is important is because you will see questions like this on your EOC, and so you need to have at least seen it and experienced it so that when this shows up on a test, it's not the first time you've ever seen it. So first thing I'm going to do is make this little T look like the box from yesterday. So it has 4 little sections so that I have this box. Makes it way easier. Then I'm going to take this polynomial and fill it in with algebra tiles into my box I just made. So x squared comes first, so I'm going to draw an x squared. It's just a big square. This plus 6 is going to go down here in the bottom right, and I'm going to fill in 6 ones. Now to make my 5x, I'm going to have to make it into this and this part. So I've got to make these two total up to be 5. Well, this made 3 pretty little rows, so I'm going to put 3 x's right here to line up with my 3 rows. And then I'm going to put 2 x's here because they line up with my 2 rows, and so I have 5x total. So now I'm going to factor x squared and 3x. The only thing they have in common is an x. And then 2x and 6, what they have in common is a 2. And then for x squared and 2x, all they have in common is an x. And then for 3x and 6, the only thing they have in common is a 3. So my 2 factors become x plus 2 and x plus 3. So that's how we do it with algebra tiles. You will see some of those on your assignment tomorrow, so it's good practice. But that's what it looks like. Now let's factor algebraically. We're going to do 4 problems, and then if there's time, we'll fit in a word problem. If not, we'll talk about it tomorrow. But I have x squared minus x minus 12. It's really easy whenever the x squared does not have a leading coefficient, meaning it does not have a number in front. So what you're going to do is take this last number, which is negative 12. Okay, we're going to draw an x that looks like this, and we're going to put the negative 12 right here because that's the last number. And then we're going to put down here in the bottom of our x the number in the middle. Well, there is a negative 1 in front of that x, so negative 1 goes right here. Now I'm going to list in this chart all of the factors that I can think of for negative 12. So I have negative 1 times 12 and 1 times negative 12. Then I have negative 3 times 4, and then I have 3 times negative 4. I'm going to go through this list of factors until I find the pair that adds up to be negative 1, this number in the bottom of the x. And so in order to get negative 1, it would be this pair of numbers, 3 and negative 4. They multiply to make negative 12. They add to make negative 1. So my numbers are 3 and negative 4. These 2 numbers are going to help me factor this. Now you have 2 options here. You can either factor this by grouping, or you can factor this with the box method. I am going to go ahead and use the box method because when it's set up this way, it's real simple to just plug everything into the box. But I'll do one with grouping in a second so you can see them both. So the x squared goes here, this minus 12 goes in this box, and then these 2 numbers that I came up with for the x are going to go in these other 2 boxes, and they have to have the variable on them, so I have 3x and negative 4x. So now the greatest common factor here for x squared and 3x is just going to be an x. The greatest common factor here, since both of these are negative, has to be a negative, and between 4 and 12, that's going to be a 4. Now for this column, the greatest common factor here is going to be an x. And for this column, the greatest common factor is a 3. So my 2 factors for this problem are going to be x minus 4 from this side, and then x plus 3 from across the top. So if I multiplied these 2 things together, this would be the answer I got. So let's try another one. I have this x squared plus 11x plus 28. And I'm going to do the same thing. I'm going to draw my x. Because this doesn't have a leading coefficient, the last number goes right here. It should be a 28. If this has a leading coefficient, things change. And then the number in the middle, 11, goes right here. So now what I'm going to do is I'm going to list my factors of 28 because I need 2 factors of 28 that add up to make 11. And so here's what I know. I have 1 times 28, 2 times 14, 4 times 7, and that's all I can come up with. So I'm going to look at my numbers. 4 times 7, if I add them up, make 11. So this becomes 4 and 7, so these are the numbers I want. So I'm going to do grouping method this time because I did box for the last one. So I'm going to rewrite this problem, and instead of putting 11x, I'm going to split it up into two pieces, 4x and 7x, because they add up to make. So I'm going to rewrite this as x squared plus 4x plus 7x, because if I combine those, it makes that term in the middle. I just split it up into the two things that make it. Then I get to group and do GCF. Well, greatest common factor for this group is just an x. And so what's left when I factor out the x is x plus 4. And the greatest common factor for this group is a 7. And so what's left when I factor that out is x plus 4. Just like yesterday, my parentheses match up. So one of my factors is x plus 4, and the other factor is x plus 7. So now let's do one that has a leading coefficient, because now when the number has it, there's an x squared in front of a number in front of the x squared, things change. I'm still going to start with the x, but now instead of the last number going right here, I have to multiply the first number times the last number. So 3 times 4 gives me 12. And then the middle number still goes down here. So I'm going to list my factors of 12. I have 1 times 12, 2 times 6, and 3 times 4. Well, the two of these numbers of these factors that add up to 8 are these two. So I get 2 and 6, because 2 times 6 makes 12, and 2 plus 6 makes 8. That's how the little x works. So these are my numbers. We're going to group again. So I'm going to rewrite this as 3x squared. And instead of 8x, I'm going to do 2x plus 6x, because that adds up to make 8x. And then I'm going to group. So the greatest common factor for this first set of parentheses is just going to be an x. And when I factor out x, I get 3x plus 2 is left. And my greatest common factor for this set of parentheses is going to be a 2. When I factor out that 2, I get 3x plus 2 left. So yay, look, my parentheses match. So one of my factors is 3x plus 2, and the other one is x plus 2. Done. So let's try one more, just for the sake of trying one more. This one has a leading coefficient as well, so you make your x, and you're going to multiply first number times last number. Well, 4 times 5 is 20, and the middle number is 9. So we're going to list our factors of 20. Of 1 and 20, I have 2 and 10, and I have 4 times 5. Well, 4 times 5 are the ones that add up to make 9. And so this time I'm going to draw and do the box method. So 4m squared comes first. 5, because it's the last number in my polynomial, goes here, and then the 4 and the 5 go here, and they have to have the variable on them, so you have your m's. Now we do greatest common factor. So the greatest common factor for this row right here is going to be 4m, and for this row right here is 5. And the greatest common factor for this column is just m, and for this row or column is 1. So my two factors are going to be 4m plus 5 and m plus 1. So that is factoring part 1. We will add stuff to it tomorrow and make it a little tougher. But for now, this is all you have. You can either use grouping or box method. It doesn't matter which. But you always have to worry about doing your x and having your two numbers that multiply to the top and add to the bottom. And so there we go. I will see you tomorrow. Have a good rest of your evening.